Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 2 video on the chapter of physical quantities and measurements, where I will solve 10 multiple choice questions, that is numerical problems based on the topic of density of a substance. In the previous part 1 I have discussed all the concepts and formula of density of a substance. So the 10 numerical problems that I will solve in this video is based on the concepts that I have discussed on in the part 1 video. If you like this video, if you find this video beneficial, then please like it, share it with your friends, and if you want to support me, then please subscribe to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's start solving the 10 multiple choice question numerical problems on the topic of density of a substance. Okay. So the first question says that the density of air is x gram per liter. Express it in SI and CGS unit. Okay. So the density is given as x gram per liter. X gram per liter. Okay, so let's first convert this unit, that is x gram per liter, in SI unit. So I have to convert the gram to kilogram and the liter to a meter cube. Okay, regarding volume of a substance, regarding the unit of volumes, you must it is advisable that you remember this conversion formula, that 1 liter is equal to 1000 centimeter cube. 1 milliliter is equal to 1 centimeter cube, and 1 centimeter cube is equal to 10 to the power minus 6 meter cube. This will help in solving the problem. Okay, so I have density is given as x gram per liter. So I know if I want to convert x gram to kilogram, this will be x multiplied by 1 gram is 10 to the power minus 3 kilogram. And if I want to, so I have to now convert the liter to meter cube. Okay, so now I know that 1 liter is 1000 centimeter cube, and so this is 1000. I know this is 1000 centimeter cube. Now again I will convert the centimeter cube to meter cube. So this is x multiplied by 10 to the power minus 3 kilogram divided by, I have 1000 means 10 to the power 3. So 1 centimeter cube is equal to 10 to the power minus 6 meter cube. So this will be 10 to the power minus 6 meter cube. If I simplify the numerical part, I have okay, so this will be x multiplied by 10 to the power minus 3. The 10 to the power minus 6, 1 by 10 to the power minus 6 is equal to 10 to the power 6. So 10 to the power 6 divided by 10 to the power 3, this much kilogram by meter cube. This, after further simplification, we have, so this cancels this with 10 to the power 3. So this is equal to x kilogram by meter cube, which is equal to x kilogram per meter cube. So the density of air it was given as x gram per liter, which is equal to, in SI unit, it is equal to x kilogram per meter cube. So this is the SI unit. the value of the density of air in SI unit. Okay, let's convert the given density of air in CGS. Okay, so again we have I will start from here. I will continue from this point. Okay, so let's directly convert. Uh, so we got rho is equal to x kilogram per meter cube. Now in CGS, if I want to convert uh, the density, if I have, we know the formula. How do we convert the value of density from SI to CGS? We just multiply by 10 to the power minus 3. So this will be clearly x multiplied by 10 to the power minus 3 gram per centimeter cube. So if you are not that familiar with the conversion of a unit of density from SI to CGS and vice versa and all the related concepts, I will suggest you that you please watch the part 1 video. Okay, so this is the density of air in CGS unit. Okay, let's see question number. Now if I do any kind of calculation mistake, or if I am applying any concepts incorrectly, please do let me know in the comment section. I will highly appreciate that. Let's see the next question. Question number 2 says a block of wood of density. Now please note that in most of the problems I will be using variables like x, y, z, so that to save time in doing actual calculation of actual mathematical calculation. To avoid mathematical calculation, numerical simplification, I am using the values. I am using variables as the values like x, y, z. I hope the main idea is that you are able to apply the concept correctly to solve the problem. Okay, the next problem says that a block of wood of density x gram per centimeter cube has a volume of y ml milliliter. So y milliliter. Find the mass of the wood in kilogram. Okay, so what is given? The density is given as x gram per centimeter cube. So the density is given in CGS unit. Okay, and the volume is given as y milliliter. Ml means small m, capital L means milliliter. Okay, we have to find the mass. Okay, so we know that from the formula of density is equal to mass divided by volume, or this implies mass is equal to density into volume. So this will be x gram. Now since the question has asked the mass to be in kilogram, so let's kilogram. So let's convert the density in the SI unit, and also let's convert the volume in meter cube. Okay, so this is equal to, we know how do we convert the value of density from CGS to SI. We just multiply with 10 to the power 3. So this will be x multiplied by 10 to the power 3 kilogram per meter cube. Okay, fine. And the volume y ml, how do I convert ml into meter cube? I know that okay, so y ml milliliter, so this is equal to, milliliter means 10 to the power 1 by 1000 liter. So this is 10 to the power minus 3 liter. Okay, I think the better way is that we know that 1 milliliter is equal to 1 centimeter cube. So I can write it. The volume is given as y milliliter, which is nothing but y centimeter cube, because we know that 1 milliliter is equal to 1 centimeter cube. Now I have to convert this centimeter cube to meter cube. So this will be y multiplied by 10 to the power minus 6 meter cube. Okay. So now I have converted the value of density and volume in SI unit. Now I can directly, if I apply the formula, I will directly get the mass in SI unit, that is kilogram. Okay. So mass is density into volume. So density in SI unit is, we got x multiplied by 10 to the power 3. This is kilogram per meter cube. So this was density multiplied by volume. Volume we got as y multiplied by 10 to the power minus 6 meter cube. So this is equal to, you will see that meter to the power m to the power minus 3 will cancel out with m to the power 3. So this is x multiplied by y multiplied by 10 to the power 3 multiplied by 10 to the power minus 6, this much kilogram. And this, after further simplification, is xy multiplied by 10 to the power minus 3 kilogram. So this is the mass of the wood in kilogram. Okay, let's see the next problem. Question number 3 says, the density of aluminium is rho 1 gram per centimeter cube, and that of brass is 4 by 5 into rho 1 gram per centimeter cube. So we can see that the density of aluminium is 4/5. The density of brass is 4/5 of the density of aluminium. Okay. Let V1 centimeter cube of aluminium has a mass of m1 gram, and V2 centimeter cube of brass has a mass of m2 gram. Okay. Then which of the following statements are correct? Okay, so before, the option A says that if m1 equals to m2 implies v1 equals to v2. So this means that if the mass, if we take equal mass of aluminium and the brass, then their volume must be same. Option B says if we take equal volume of aluminium and brass, then the mass of brass should be greater than mass of aluminium. This way, similarly, we have option C and D. Okay. Now let's see. Using the formula of density, which is mass per volume, let's see what equation or relation we get from the given data. Okay. So since it is given that V1 centimeter cube of aluminium has a mass of m1 gram. Now the density, please note that the density is not changing. The density of aluminium or brass is not changing. It is just given that the density of the two substances are given, that is aluminium and brass, in terms of rho 1, and it is also given that V1 centimeter cube of aluminium has a mass of m1 gram. So I can say that the density of aluminium is rho 1. This is equal to the mass. If it is given that the mass of m1 gram, it is given that the volume of V1 centimeter cube of aluminium is m1 gram. So from here I can get the density of aluminium, which is given by using the formula mass by volume. So this will be m1 by v1, this much gram per centimeter cube. And since the density is also given to be rho 1, so I can say rho 1 is equal to m1 by m1 by v1. There will not be this unit. So rho 1 is m1 by v1. Similarly, this is for aluminium. This is for aluminium. For brass, we have the density of the brass is given to be 4 by 5 rho 1. This should be equal to the mass, m2 gram of the brass is having a volume of V2. So we must have m2 divided by V2. So this is these two relation we are getting from the given data. From here we have to answer the question. Okay. Now m1 is equal to m2, then v1. Okay, so from here for aluminium we have v1 is equal to m1 by rho 1, and for brass we have v2 is equal to m2 divided by 4 by 5 rho 1, which is equal to 5 by 4 multiplied by m2 by rho 1. So v1 is m1 by rho 1 and v2 is 5 by 4 multiplied by m2 by m2 by rho 1. So clearly we can say that v2 is equal to 5 by 4. We know m2 okay. v1 is m1 by rho 1, okay, and v2 is 5 by 4 5 by 4 rho 1 multiplied by m2. Okay, so we have this. Okay, now let's see, we have to check each options separately. Now if let's see if option A is correct or not. It is saying that if m1 is equal to m2, so let's verify all the options individually. Now m1 equals to m2 will imply that v1 m1 equals to m2 will imply that v2 we can say v2 is equal to 5 by 4 rho 1 multiplied by m1. Now this is equal to m1 by rho 1 we know is v1. So this is equal to 5 by 4 multiplied 5 by 4 v1. So v2 is equal to 5 by 4 v1. So clearly v2 is not equal to v1. So option A is incorrect. This is not a correct statement. Let's see option. Let's check option B. If we have v1 equals to v2, it is if v1 becomes equal to v2, what do we get? This implies for aluminium v1 is m1 by rho 1. So we get m1 by rho 1 is equal to what is v2? v2 is 5 by 4 rho 1 m2. We are having this. Okay. Now this implies I can cancel out rho 1 from both sides, and I will get m1 is equal to 5 by 4 M2. So M1 is equal to 5 by 4 times M2. Clearly, 5 by 4 M2 is definitely greater than M2, since 5 by 4 is 1 and 1 by 4. So M1 we are having, if V1 is equal to V2, we are having M1 is equal to 5 by 4 times M2, which is greater than M2. So we are having M1 is greater than M2, but it is given in the choice B, it is given that M2 is greater than M1, which is wrong. So this statement is also wrong. Okay, let's see choice C. And okay, so choice C, what is the option? C is saying M1 equals to M2 implies V2 greater than V1. Okay, so when we were having M1 is equal to M2, for the in the choice A, we saw that when M1 is equal to M2, V2 is equal to 5 by 4 V1, and 5 by 4 V1 is definitely greater than V1. So we have V2 is greater than V1. So clearly choice C is correct. Choice C is correct. Now, since these are all single correct choice, multiple question, only one choice will be correct. But anyway, let's see the choice D. No, if for choice D, if V1 for choice D is saying that if V1 is equal to V2, we have already seen in choice B. If V1 is equal to V2, we are having M1 greater than M2. So definitely choice D is also incorrect. It is saying that if V1 is equal to V2, it means this implies M1 is equal to M2, which is false, because we have found in choice B, for choice B, that if V1 is equal to V2, M1 is equal to 5 by 4 times M2. Clearly we can say that M1 is greater than M2. So the correct choice is C. C is the correct choice. Okay, let's see the next problem. The density of the material of a paper is x gram per centimeter cube. The mass of the paper is y gram and its length and breadth are p centimeter and q centimeter respectively. Then the thickness in centimeter of the paper is. Okay, so we can consider a paper as so a thin paper, sheet of paper, we can consider it as a cuboid. That is, it is having a very small thickness and a length and breadth. So it is given that the mass of this sheet of paper is given as y gram. Okay, the density of the paper, that is the density of the material of the paper, is also given as x gram per centimeter cube. Now we need to find the volume. We need to find the problem is asking to find the thickness of the paper. If we know the thickness of the paper, we will get the volume, and from the volume we can apply the formula that density is equal to mass by volume. From the given fact of mass and density, we can first find the volume of the paper, of the sheet of the paper. Okay, so clearly volume will be equal to mass by density, and this will be mass is given as y gram divided by density is x gram per centimeter cube. So we are having the volume of the paper is y by x centimeter cube is the volume of the paper. Okay, now we have to find the thickness of the paper. So let's say, so the length and breadth of the paper, the length and breadth of the paper was given as length was p centimeter, uh, p centimeter. The breadth was given as q centimeter. Let's say the thickness be h centimeter. So we will also have the volume will be equal to length, breadth into height. Since a paper is you can consider a paper is a cuboid, we know the volume of a cuboid is length, breadth into height. So this will be p multiplied by q multiplied by h, this much centimeter cube. So this will be equal to y by x centimeter cube. So this will imply from here we can easily get this happening. We can easily find h. So this implies p q h is equal to y by x. So this implies h is equal to y divided by x p q, this much centimeter. So the thickness of the paper will be y by xpq, y by xpq. So the choice D is the correct choice. Okay, let's see the next problem. Question number 5. X liter of a liquid weighs y kgf. Kgf means kilogram force. It is a gravitational unit of force. Now weight of a substance or weight of a body, the unit of weight of a body is the unit of force. We know that. Side note, I hope you are already aware from your previous class, or you also have the chapter force and pressure, that weight of a body, if I denote it with the letter W, is nothing but its mass multiplied by g, where g is the acceleration due to gravity, which is considered to it has a value of 9.8 meter per second square in SI unit. 9.8 is also approximately sometimes considered as 10. Anyway, so weight of a body is mass into g, small g, where g is the acceleration due to gravity, or the gravitational acceleration due to Earth's gravity. Okay. Now, what does it is given that the weight of the body is given in a gravitational unit. That is, it is given that weight is equal to, okay, so the weight is given as y kgf. Now, what is kgf unit? 1 kgf, we know that 1 kgf is equal to weight of one weight of a body, of mass 1 kilogram, So the force, the gravitational force that acts on a body of mass 1 kilogram, that is known as, expressed in the gravitational unit as 1 kgf. Similarly, 1 gf is nothing but the weight of a body of mass 1 gram. Okay. So from here, since it is given that the weight of the liquid is y kgf, I can say that the mass of the liquid is nothing but y kilogram. The mass of the liquid is y kilogram, and the volume is given as to be x liter. We have to find the density. All the choices, you see that in all the choices are given both in SI unit, that is kilogram per meter cube, and also in gram per meter cube. So we have to you can find the weight, you can find the density in SI unit, and then you can convert that to CGS unit and match which of the choice is correct. So let's first find the density of the liquid in SI unit. So I am having the mass as y kilogram, okay, and the volume is given to be x liter. Now I have to convert liter to meter cube. Okay, so I know that the 1 liter is 1000 centimeter cube. So this is equal to x multiplied by 1000 centimeter cube. 1 liter is equal to 1000 centimeter cube. And again, I know that 1 centimeter cube is equal to 10 to the power minus 6 meter cube. So I have converted the volume, expressed the volume, given volume in meter cube, that is x liter is equal to x multiplied by 1000 multiplied by 10 to the power minus 6 meter cube, and this is equal to x multiplied by 10 to the power minus 3 meter cube. So this implies what will be the density? Density will be equal to mass by volume. Mass is y kilogram and volume is x multiplied by 10 to the power minus 3 meter cube. So this becomes y multiplied by 10 to the power 3 divided by x, this much kilogram per meter cube. So this is the value of the density in SI unit. Let me see if any of the choices matches. The choice the choice A and D are expressed in, are given in SI unit. We can clearly see that none of the choices A and D is matching with the answer. That is, the density we have found is 1000 y by x kilogram per meter cube, and it is not matching with any of the choices A or D. Okay, now let's try to convert the density into a CGS unit, that is gram per centimeter cube. So we know the formula to convert from SI to CGS of unit of value of density. If to convert the value of density from SI to CGS, we just multiply with 10 to the power minus 3. So this will be y multiplied by 10 to the power 3, we have this. This will be multiplied with 10 to the power minus 3, and the unit will be gram per centimeter cube. After simplification, this becomes y by x gram per centimeter cube. So this is the value of the density in CGS system, and we see it is matching with option B. So choice B is the correct choice. Okay, let's see the next problem. Question number 6. Bottle A contains x ml of liquid X of density rho x gram per centimeter cube, and bottle B contains y ml of liquid Y of density rho y gram per centimeter cube. Okay, if the mass of bottle A is 5 by 2 times the mass of bottle B, then the ratio rho x is to rho y is. So we have to find the ratio of the density of liquid X and the density of liquid Y. Okay. So for liquid X, what we are having, let's apply the formula of density in the given information and see what we get. For the liquid X, it is given that the bottle A is having the liquid X, and the density of the liquid X is rho X, gram per centimeter cube, and the volume of the bottle is X ml. So for the liquid X or bottle A, we are having the volume is given to be X ml. Now since the density is given in gram per centimeter cube, we have to convert ml to centimeter cube. We know that 1 ml is 1 centimeter cube. So this will be X centimeter cube. And the density, let's denote Vx to be the volume of the bottle A containing liquid X. And no, it's fine. Let's say for liquid X, that is the bottle A containing liquid X, we are having the volume is X ml, which is X centimeter cube, and the density is given to be rho X, gram per centimeter cube. So from here we can say that the mass of the bottle A, I am denoting it with MA. This means the mass of the bottle A will be equal to the mass of the liquid X, X ml of liquid X. Now please note that even though it is not clearly mentioned, but we should ignore the mass of the bottle, it's the mass of the empty bottle, the mass of the empty bottle. So we can assume without any problem that the mass of the bottle will be equal to the mass of the X ml of liquid X. So this will be, if we denote MA to be the mass of the bottle A containing liquid X, it will be X multiplied by rho X, this much gram. Volume into density, if you multiply, the volume was X centimeter cube and the density was rho X, gram per centimeter cube. If you multiply these two, you will get X into rho X, gram. Okay. Now let's see for liquid Y. Similarly, for liquid Y, the volume is given to be Y ml, which is equal to Y centimeter cube. 1 ml is equal to 1 centimeter cube, and the density is given to be rho Y, gram per centimeter cube. So from here we can say, if I denote the mass of the bottle B to be MB, it will be volume into density. This is equal to Y. This will be equal to Y multiplied by rho Y, this much gram. Okay. Now in the problem it is also given that the mass of bottle A is 5 by 2 times the mass of bottle B. So it is given that MA is equal to 5 by 2 times MB. Okay, so this implies the mass MA, the mass of liquid bottle A having liquid X, we have found to be X multiplied by rho X, this much gram. This is equal to 5 by 2. Mass MB is the mass of the bottle B containing liquid Y. This we have found to be equal to Y multiplied by rho Y, this much gram. Okay, so we have to find the ratio of rho X and rho Y. Okay, so this implies now we can cancel out the gram, that is the unit, from both the sides. Okay, so now what we are having is X rho X is equal to 5 by 2 y rho y. We have to find the ratio of rho x and rho y. So this implies rho x divided by rho y is equal to 5 by 2 y by x, which is equal to 5y by twice x. So from here we can clearly say that the ratio of rho x and rho y is nothing but 5y is to 2x. 5y is to 2x will be the ratio of rho x and rho y. So the correct choice will be choice D. D is the correct choice. Okay, let's see the next problem. Question number 7. A right angled cone of height p centimeter and radius q centimeter has a mass of m kilogram. The density of the cone is, okay, the mass of the cone of a right circular cone is given to be capital M kilogram, and the height of the cone is p centimeter and the radius is q centimeter. We have to find the density. Now from the given dimension of the right angled cone, we can easily find the volume of the cone. We know that the volume of the cone is, what is the volume of a cone? I guess it is pi by 3 r square h. The volume of a cone V will be equal to pi by 3 r square h, where r is the radius of the cone and h is the height. So in this case, in this problem, it will be pi by 3. The radius of the cone is given to be q, so this will be q square, and the height is given to be p, this much. So this much centimeter cube. Since all the units, the dimensions are given, the height and radius of the cone are given in centimeter, so this will be centimeter cube. Okay, so the volume of the cone is pi by 3 q square p centimeter cube, and the mass is given in the mass is given to be m kilogram. So we have to find the density. In the choices, the densities are given both in SI unit and CGS unit. Okay, let's first try to see what will be the density in SI unit. Okay, so let's see. We have found the volume to in centimeter cube. So this will be pi by 3. If I want to convert the volume to in SI unit, this will be pi by 3 q square p. So 1 centimeter cube is equal to 10 to the power minus 6 meter cube. Okay. So the density is mass by volume. Mass is given as capital M, this much kilogram, and the volume is pi by 3 q square p multiplied by 10 to the power minus 6, this much meter cube. This becomes, after simplification, we have, this is okay, so 3m multiplied by 10 to the power 6 divided by pi q square p, this much kilogram per meter cube. So this is the value of the density in SI unit. 3m multiplied by 10 to the power 6 divided by pi q square p. Is it matching with any choice? Choice A, no. Choice C, yes, no. Wait a minute. 3 I think in the choice C there is a mistake. There should be one m over here. Over here there should be 1 multiplied by m. I think I did a mistake while giving the choice. So I think the density is matching with the choice C. So since we are having 3m multiplied by 10 to the power 6 divided by pi q square p, the choice C is it is matching with choice C. Okay. Uh, let's see what will be if we want to convert this value in the CGS unit. What will be the value? Uh, we know that to convert the value of density from SI to CGS, we just multiply the value with 10 to the power minus 3. So this will be 3m. We have 10 to the power 6 divided by pi q square p. This whole will be multiplied by 10 to the power minus 3, and the unit we will get in gram per centimeter cube. If we simplify this further, we have 10 to the power 6 multiplied by 10 to the power minus 3 will be 10 to the power 3, that is 1000. So this will be 1000 multiplied by 3 is 3000. So 3000 m divided by pi q square p, this much gram per centimeter cube. Is it matching with any of the choices? Choice A is 3m, no. Choice B is 300 m. So choice A and B are incorrect. The actual value in CGS is 3000 m by pi q square p gram per centimeter cube. So the given choices in CGS is not matching. Uh, the only choice which is matching is C, even though the M, capital M, was missing in the given choice. So this is the correct choice. 3m multiplied by 10 to the power 6 divided by pi q square p, this much kilogram per meter cube. This is the density of the cone in SI unit. Okay, let's see the next problem. Question number 8. If the density of a sphere, now sphere, pi by 3. What is the okay? So if the density of a sphere is reduced to 1/8 of its original value, if the density of a sphere is reduced to 1/8 of its original value, then the radius of the sphere becomes x times its original radius. Assume the mass remains the same, then value of x is. Okay, so we have to consider a sphere. So we have to consider a sphere of mass, let's say capital M. Let's say this is a sphere, this is a solid sphere. Let's say let's say the radius of the sphere is let's say the radius of the sphere is small r. So we are having, let's say this is the sphere. Consider the radius of the sphere to be small r. Now what is this is a solid sphere, so what is the volume of a solid sphere of radius r? What is the volume? I forgot the volume of a sphere. This is really very bad. Give me a second. I will quickly check in the textbook what is the volume formula of volume of a sphere. This is really bad. It is 4 by 3 pi r cube. 4 by 3 pi r cube. So the volume, let's say the original radius of the sphere was small r. So the volume will be 4 by 3 pi r cube. Remember the mass, and it is saying that when the density is reduced to 1/8 of its original value. Let's say the original density was rho. Let's say originally uh, the sphere was having a radius small r, and the mass was, let's say, m. Let's say mass was m. Mass was m, capital M. The density was rho, and the radius was small r. Now, keeping the mass same, that is, we are just reshaping the sphere. Consider, so the new radius is 1/8 of its original value. That is, the sphere is contracting. The radius is becoming less, 1/8 of the original radius. So the sphere is contracting. Now, if the sphere is contracting, definitely. The density of the sphere is reduced to 1/8 of its original value. So the density is reducing. So if the density is reducing, definitely the volume will increase. The volume has to increase because the mass is same. So the question is asking, if the density is reduced to 1/8 of its original value, then the radius of the sphere becomes x times its original radius. Okay. Let's say, so definitely when the density, so the mass is constant, the density is becoming less, which means that the volume is increasing. So let's say originally the sphere, the radius was r, mass is m, mass is constant, and let's say the density was rho. Now in this scenario, we know the volume will be 4 by 3 pi r cube, and let's say when the density was reduced to the density was reduced to 1/8 of the original density, that is rho. In the latter case, when the density was reduced, let's say the mass is remaining the same, the density is 1/8 of the original density, that is rho. Let's say in that state, the radius has become r dash. So definitely the volume, the radius will r dash will be more than r, because if you decrease the density of the sphere, it means that the volume is becoming large. The volume is increasing. Okay. We have to find x. It is saying that when the density is reduced to 1/8 of its original value, the radius of the sphere becomes x times its original radius. We have to find x. Okay. The key concept is that the mass of the sphere is remaining the same. Okay. In the first scenario, we can say that the mass is, we know that mass is volume into density. This is equal to 4 by 3 pi r cube, and the original density we have considered to be rho. Okay. In the second case, also we can say the mass will be equal to the volume, which will be 4 by 3 pi r dash cube multiplied by the density, which has become 1 by 8 of the original density, that is 1 by 8 p. So this is equal to, if I simplify, this becomes pi r dash cube rho divided by 6. Pi r dash cube rho divided by 6, where r dash is the new radius of the sphere. when the density has become 1/8 of the original density. Okay. Now we can equate uh, from both the sides, from both the cases, we can equate the mass, and we will get that 4 by 3 pi r cube rho will be equal to pi r dash cube rho divided by 6. From both the sides, we can cancel out pi rho, and we get 4 by 3 r cube is equal to r dash cube by 6. So this implies, from here we can say that from here we get r cube divided by r dash cube is equal to 3 by 4 multiplied by 6, which is equal to 1 by 8. So this implies r by r dash whole cube is equal to 1 by 8. 1 by 8 means half, cube of half. So clearly this means r by r dash is equal to half. This means r dash is equal to twice r. So from here we can say that x is equal to 2, because in the problem it is given that when the density of the sphere was reduced to 1/8 of the original density, the radius becomes x times the original radius, and we have found that the new radius r dash is equal to 2 times the original radius. So x is 2. X is 2. So the correct choice is A. A is the correct choice. Okay, let's see the next problem. Question number 9 is the conceptual problem. It is not numerical. Which of the following is constant anywhere in the universe? The answer is mass. Always remember that mass never changes. Whether you heat or cool the substance, or you deform the substance, you take it anywhere, you change the location, mass always remains same. Mass can only be changed if you add more content of the substance. More content means more particles, or remove some content, that is remove some particles from the substance. Then only mass can change. Otherwise mass always remains the same. Now volume, which of the following is constant anywhere in the universe? Now definitely volume will not be the same anywhere, because you know that if you at a high altitude, the density the density of a substance gets the density, since mass always remains the same, there will be variation of density in a substance if you go at high altitudes, and if the density changes, definitely the volume will change. So definitely volume, density, and weight will also change, because weight is nothing but mass into acceleration due to gravity, g, and g varies from g varies from the surface, varies from the surface of the earth. The value of g is maximum at the surface of the earth, and if you go closer towards the center of the earth, more towards the center of the earth, then the value of g will be less. Also, if you go above the earth's surface at high altitudes, the value of the g will be less. So mass is the only quantity of measurement. Mass is the only attribute of a body that remains same anywhere in the universe. This is a very conceptual problem. You must clearly understand this. Okay, question number 10 says an equal mass of three substances A, B, and C having densities rho A, rho B, and rho C, where it is given that density of A, that is rho A, is less than rho B, that is the density of B, and density of B is less than density of C, that is the density of the substance A is the least and the density of the substance C is the maximum. Okay, and equal mass, both the substances A, B, and C are having, we are considering equal mass. Okay, and they are having volumes VA, VB, and VC respectively. Then which of the following option is correct? So the choices are asking what will be, how will the volume of the three substances be related. Okay, so for substance A, what we are having is mass A. If I denote Ma to be the mass of the substance A, this will be equal to volume into density, so which will be Va multiplied by its density, which is given to be rho A. For substance B, similarly, the mass, if I denote Mb to be the mass of the substance B, it will be equal to the volume of the substance B, which is given to be Vb multiplied by its density, rho B. Similarly, for substance C, I will have Mc is equal to Vc multiplied by rho C. Okay. Now, I have to find out how the volumes are related. Okay. Now, the key concept is that all the substances A, B, and C are having equal mass. That is, we know that Ma is equal to Mb is equal to Mc. Okay, so I can say that let's say all the masses are equal to M. Masses are equal to M. So I can say that Va multiplied by rho A is equal to M. So from here we can say Va is equal to M divided by rho A. In this way, similarly, we will have Vb will be equal to M divided by rho B, and Vc will be equal to M divided by rho C, where I have considered capital M to be the mass of each of the substance A, B, and C. Now, from this result, how do we know whether, how do we compare Va, Vb, and Vc? It is given that rho A is less than rho B and rho B is less than rho C. Okay. Now, the thing is that if this is a mathematical concept, that if rho A, it is given that rho A is less than rho B. So rho A less than rho B implies that the reciprocal, if I consider the reciprocal of the densities of the substance A and B, that is 1 by rho A will be greater than 1 by rho B. This is a mathematical concept that two quantities, let's say X and Y are two quantities and they are positive quantities. Obviously, the density of a substance will always be positive. So, if X is greater than Y and X and Y are positive quantity, positive number, this will always imply that 1 by X will be less than 1 by Y. Similarly, if it was X less than Y, this will imply 1 by X is greater than 1 by Y. So I have 1 by rho A less than greater than 1 by rho B. From here, I can always, in an inequality or equality, I can always multiply both the LHS and RHS by a non-zero positive quantity and the inequality remains the same. I have 1 by rho A is greater than 1 by rho B. If I multiply both the side with capital M, the mass of the substance is a positive quantity. The inequality will remain the same. So M by rho A will be greater than M by rho B. This implies what is M by rho A? M by rho A is nothing but VA. This means VA is greater than VB. So I got the relation between VA and VB. I got that VA is greater than VB. Now, clearly, right away, I can say that choice C is the correct choice, because in choice A it is saying VA is equal to VB is equal to VC, which is incorrect because we have found that VA is greater than VB. So choice D is also incorrect, and choice B says VA is less than VB, which is incorrect. Now I will also check whether VB is greater than VC or not. So so we know that the density of a substance B is given to be less than the density of substance C. So this implies that the reciprocal 1 by rho B will be greater than 1 by rho C. This will imply if I multiply both the sides with M, I will have M multiplied by rho B will be greater than M multiplied by rho C, and this implies M by rho B is nothing but VB is greater than VC. So we got VA is greater than VB, and we got VB greater than VC. So these two will imply that VA is greater than VB. VA is greater than VB is greater than VC. Hence, this is the correct relation between VA, VB and VC. So the correct choice is choice C. So this was the last question. This brings to an end in solving 10 conceptual problems based on the concept of density of a substance. If possible, I will try to solve more problems. I will try to solve another set of 10 problems on the concept of density of substance, which I have covered in part 1. So 20 problems, if you solve these 20 problems on the density of a problem, it will cover most variation of the problems. So the next video, part 3, I will not solve the next 10 problems on this topic of density of substance. Rather, I will start discussing a new topic, which I guess is the measurement of density of liquid and solids using the various devices like measuring cylinder, Eureka can, those concepts. And then I will possibly solve another set of 10 problems based on the density of a substance. So this was all regarding solving numericals, 10 problems on the concept of density of a substance. I will end the video here. Once again, if this video was useful, then please like it, share it with your friends, and if you want to support me, then please subscribe to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So thanks for watching, and until the next video, take care and bye.